of Research Organization for Food and Agriculture, National Innovation and Research Agency, BRIN. Selamat datang Ibu Puji di Osaka University. We also have a distinguished guest, Vice Rector from IPB University, Professor Derajat Martianto is here.
Hello.
As a guest.
Good afternoon.
Yes. And also, last but not least, we have Tempe Queen and Tempe King. Miss Ando and Mr. Adriano. So similar name.
Oh my God. What a nice name.
Dr. Adriano is also called Ando, and Miss Eri Ando is also called Andosa. So they have very similar name. So welcome to Osaka University. To Ando-san, also we call her Tempe Queen, Japanese Tempe Queen. Okay. So I'm very happy to greet everyone, especially we also have a prominent scientist from Indonesia, Professor Made Astawan, is joining us live from Bogor. Hello.
Yeah, good afternoon all.
Yes, Pak Made. Pak Made is our long-term collaborator and very prominent scientist who consistently dedicate his life work to promoting tempe in Indonesia and worldwide through his many research scientific achievements. Prof. Made, we're very honored to have you with us from Bogor.
Yeah, thank you very much for inviting me.
Yeah, Pak Made later on will be giving his latest research findings as well regarding the effect of tempe, health benefits of tempe for promoting reduction risk of diabetes mellitus, ya Pak ya? Yes, okay. So before we start, because we have the Honorable Consul General Diana, who is here with us and always promote us and support us through and through, all of Indonesians who are here in Osaka feel very happy to welcome first female, Consul General in Osaka, who consistently support all activities, positive activities, including this kind of scientific activities. So, Ibu Diana, we would like to ask you to kindly offer a few words to open this event. Please, Ibu.
Okay, thank you so much, Dr. Sastia, or every day I call her Mbak Sasti, Mbak Sastia. Thank you, first of all, of course. Such a pleasure to be here amongst all the bright, future Indonesian, not only students, scientists, but also particularly tempe enthusiasts, right? So I'd like to just start because, usually in the Ministry of Foreign Affairs, when we start the opening remarks maybe, but I want to be very, very brief and also very informal, but I'd like to just mention to greet the chairman of BRIN Research Organization, chairwoman of BRIN Research Organization for Agriculture and Food, Ibu Puji Lestari, PhD. She's sitting on my right side, Professor Dr. Made Astawan, professor of the IPB University, who's also here with us. Good afternoon, Professor. Of course, Dr. Saskia Pramaputri, Associate Professor, Graduate School of Engineering, Osaka University, our dear friend. And this is, of course, my pleasure to also greet Mas Amadeus Driando Ahnan Winamo, PhD, co-founder of Indonesian Tempe Movement. And then, of course, we have with us the Tempe Queen, Miss Eri Ando. So welcome, Tempe Queen. It's such a pleasure to finally meet you. And Mbak Dela, who's celebrating her birthday today. Mbak Dela, Mas Hadi Akbar Dahlan, Mas Marvin Nathaniel Iman, PhD candidates from Graduate School of Engineering, Osaka University. Professor Derajat, of course, I will not forget to mention your name. Konnichiwa, everyone. Selamat siang. So this is definitely a distinct pleasure for me and my team to kick off the Tempe Science Talk at Osaka University in the spirit of promoting tempe as the face of Indonesian culinary food science, as well as gastro and cultural diplomacy. So I would like to, of course, take this opportunity to extend my sincere gratitude and appreciation to Osaka University, BRIN, IPB, and the Indonesian Tempe movement, and definitely Mbak Sastia for initiating this event, excellent event on Tempe Science Talks to promote more about Indonesia, especially tempe, a superfood from Indonesia in Japan. And particularly, of course, in our jurisdiction areas of Osaka, in Kansai region. I am honored to be able to join these young and bright fellows, Indonesian inspiring scientists, to talk more about tempe and their research. Tempe speakers have played their part in promoting and elevating tempe, primarily through scientific means. Colleagues, I have actually in front of me two great speeches that were beautifully prepared by my team, Mbak Risa, she's here, and also by Mas Ando. So this is a very lucky event where even as a Consul General, I'm very much supported in all my efforts to promote Indonesia here in Osaka. So this is the part of the support from all of you in preparing the speech. So I'd like to pay tribute of the speech beautifully prepared or drafted by reading it a little bit. Okay, so the world, colleagues, the world is currently looking into tempe like never before. In the face of climate change, chronic health issues, and now later we are going to hear about the benefits of tempe for the health benefit, especially in the maybe fighting against the non-communicable diseases such as diabetes mellitus. So I'm looking forward to hear about that. So in the face of those challenging issues, including food accessibility issues, tempe comes as a potential solution that not only Indonesia needs, but also world needs. Since its first documentation, the note states that since its first documentation more than 300 years ago, tempe has been a staple protein source in Indonesia. No household in Indonesia without tempe. I think in every household in Indonesia, tempe has been there, being celebrated, not only as one of the main staple food, but also maybe the snacks. Tempe becomes much more trendier right now because it's not only eaten, throughout the household of Indonesia, but now it becomes or emerging, in the world culinary, events. And then in my residence, for example, I always serve tempe so that my friends from different countries can start, getting introduced of this, beneficial, source of protein. Tempe science also picking up in the last decade with record-breaking number of publication every year. So we have our expert here later. So colleagues, today we have a great opportunity to catalyze the expansion of tempe from Indonesia to the world, starting with Japan. Given the extensive scientific research and recently successful tempe export-import from Indonesia to Japan, we have the most strategic speakers for today. Today's Tempe Science Talk will be hosted by Dr. Sastia Putri, an associate professor at Osaka University, Department of Engineering, whose PhD students will talk about the science of tempe and its relevance to improving human health through metabolomics, one of the most cutting-edge food analysis methods. It's a very sophisticated and lauded words for me, but well done. We also have a visiting co-host, a very passionate tempe advocate and activist, Dr. Driando Anan Winarno, who is the co-founder of the world's largest tempe network, Indonesian Tempe Movement, and author of the comprehensive scientific review paper Tempe Bible. Wow. Okay, so that's very very excellent. And then I would like to also note that there is also the presence of our honorable guest, Dr. Puji Lestari, the new chairwoman of BRIN, Research of Food and Agriculture, who's leading our nation's scientific activities related to food. So you have a big responsibility, Ibu, in leading this new institution or the scientific activities related to food. Also joining virtually another honorable guest in this event, Professor Made Astawan, a prominent senior Tempe scientist in Indonesia. I am so happy finally we can get introduced, even though virtually, Professor Made. Last but not least, we are very lucky to have Miss Eri Endo with us today. Eri-san is a Japanese Tempe enthusiast known as the Japanese Tempe Queen. You can see from the, how do you call it in English now? The crown, yeah, the look like a crown that she's wearing. So, to add to the, the atmosphere of her being a Tempe Queen. So Eri-san will share about the perception and potential to promote Tempe further to Japanese consumers. So of course, with all those excellent speakers in our midst, I would like to start commencing the Tempe Science Talk at Osaka University. So I hope that this event will serve as a unique platform, a catalyst to the global expansion of Tempe, starting from Japan. I wish you all a productive and excellent discussions. And thank you again for inviting me and our team from Indonesian Consul General in Osaka. Thank you so much. Arigatou gozaimasu.
Okay, thank you very much, Ibu Diana, for a wonderful speech, and it's very encouraging to have you among us, sharing your wisdom and also your support. So I think the PhD students and also academicians like myself, you're very lucky to have the full support of the Indonesian government representative here while we are away from home, but we feel that we are still very well tied to Indonesia. Thank you very much.
Thank you.
So next up, without further ado, I'm going to be giving the chairmanship to Professor Made Astawan, who will be giving us his talk today. Professor Made Astawan, the time is yours to deliver your talk whenever you are ready. So
Okay.
Professor Made Astawan is our long-term collaborator and also my teacher about Tempe. I learned so much when we started the Tempe topic. It started with just very simple research collaboration involving one student. And now our Tempe team has expanded to involve 3 PhD students and two graduate students. And we have published research papers together. Pak Made has been guiding us as well to the successful export of Tempe from Indonesia to Japan. Through his consistent guidance and commitment to small, medium-scale enterprises, we are able to enjoy all the Indonesian community Tempe directly from Bogor. So thank you, Professor Made, for your time. And now I will give you a chance to please deliver your talk. Please, Pak Made.
Okay, thank you very much.
Sorry, Pak, now the speech is, the screen is now a Word file.
Sorry. I try to share my slide. Wait a moment. Okay. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, ladies and gentlemen. First of all, I would like to thank Dr. Sastia from Osaka University as the committee who has given me the opportunity to share the results of our team's research related to Tempe. Thanks also to Professor Derajat Martianto from IPB University, Ibu Diana Stikno as a Consul General of the Republic of Indonesia, Dr. Puji Lestari from BRIN, Dr. Ramadius Driando Ahnan Winarno from Tempe Movement, and Riando Sang, of course, the member of Fukusaki Lab, and all participants who attended this event.
Now it's not a full screen yet.
Okay, for your information, we just celebrated National Tempe Day, June 6, 2020.
Professor Made, can you make the screen full screen? This now we can.
Okay.
This is not full screen.
Okay.
PowerPoint
Good.
slideshow.
It's okay?
Yes,
Okay.
okay, perfect.
Okay, this is some of our research at IPB University, like tempe protein bioavailability, tempe calcium bioavailability, tempe hypotensive activity, and also tempe hypocholesterolemic activity. But for today, I just want to share two topics about our research. The first is hypoglycemic activity of germinated and non-germinated soybean tempeh, and the second is hypoglycemic activity of fresh and overripe tempeh, especially semangit and bosok tempeh. Okay, the process of making tempe was carried out at the Indonesian Tempe House. This is the Rumah Tempe Indonesia. This Rumah Tempe Indonesia have got 4 certification, like HACCP, Badan POM, and SNI from BSN, and also Halal certification. While the experiment with thread were carried out at our department, the Department of Food Science and Technology, IPB University, the condition is like this. And for the purpose of analysis, we took blood and also some organs for further analysis. And this is the first topic about the hypoglycemic activity of germinated and non-germinated soybean tempeh. This is a germinated soybean tempeh, we call GST, and this is a non-germinated soybean tempeh, or NST. So, and this is the protein content of soybean, GST, and NST in dry basis. Yeah. So we can see the protein contents higher in tempeh as compared to soybean in dry basis. Yeah. And this is the table of the approximate composition of the NST and GST. You can see here that germination process increased the protein, crude fiber, and also moisture content. And then the NST, this one, had a significantly higher phenylalanine, leucine, phenylalanine and leucine content, but not significant difference found in another insulinotropic amino acid. So, in the amino acid in red is insulinotropic amino acids. Yeah, will trigger the beta cell of pancreas to produce more insulin. Yeah. So, why these amino acids are very important in diabetic mellitus persons, but not significant of the total here. So the GST is superior in preventing DM due to its protein content, including the bioactive peptides, of course, while the GST and NST both have the potential to prevent DM due to insulinotropic amino acid content like this. Yeah. Okay, this table showing the comparison of antioxidant in tempeh flour. We can see here that GST has had a higher, significantly higher of antioxidant capacity as compared to NST. So antioxidant actively bind the ROS, reactive oxygen species, and protect pancreatic beta cell from oxidative stress, and also can inhibit glucose absorption. You can see from this picture, this is about the IC50 value, IC50 values of alpha amylase and alpha glucosidase. Yeah? So inhibiting alpha amylase and alpha glucosidase means decrease the IC50 value, which could inhibit starch digestion, resulting in decrease postprandial blood glucose level. The lower the IC50 means the inhibitor of alpha amylase and alpha glucosidase higher. Okay, this one. So the GST was superior in preventing DM due to its antioxidant, this one, while the NST was superior in preventing DM due to content of isoflavone and also the alpha amylase inhibition IC50. Okay. Now I want to talk about the tempeh flower, increased antioxidant status and pancreatic performance of diabetic rats. So we can see from the left side of picture, this one, yeah. This is body weight development of DM rats. Yeah. So weight loss in the diabetic rats group caused by the decrease of insulin production, causing glucose cannot be processed into energy. And then we can see from this picture that NST, this one, has overcome the negative effect of DM in weight loss, because one of the prognosis of the DM is the decrease of the body weight, yeah, but NST can increase the body weight of diabetic rats. And this picture showing about the blood glucose development of DM rats, and we can also from this one that high blood glucose level indicates the inability of a pancreatic cell to produce insulin. And we can see from this picture that NST and GST, this one, yeah, the green and the yellow color, showed a higher decrease in glucose level than the positive control. Yeah, the positive control mean the diabetic rats without the treatment. And although they were not able to match the negative control, it's just the negative control or normal rats or healthy rats. This table showing the comparison of MDA and SOD level and liver of experimental rats. You can see from this picture that diet treatment had a significant effect on the MDA, malondialdehyde, and SOD, superoxide dismutase level. Yeah. You can see here that negative control, of course, had the lowest MDA and SOD content, yeah, and not significant difference with the NST. Yeah. So the high SOD activity in NST group due to isoflavone content could decrease the MDA level, and SOD as endogenous antioxidant could inhibit and neutralize free radicals. MDA and SOD level in the NST, yeah, this one, yeah, were the same as those in the negative control or healthy rats. And now I want to show about the comparison of Langerhans island and beta cell number in pancreatic tissues of experimental rats. This is pancreatic histology of rats with hematoxylin eosin staining. Yeah, it's very easy to understand this picture. This is the negative control. Had the bigger Langerhans islands, while this is the positive control, had the smallest one. And this is NST and GST is a Tempe treatment. So the Tempe treatment group had bigger Langerhans islands, but still smaller than the negative control. Yeah. And this is the pancreatic histology of rats with immunohistochemical staining. This is about the beta cell. This is the amount of beta cell. Yeah? Like here, you can see here also in the table. Yeah, this is the amount of the beta cell. You can see this is the positive control has the smallest number of beta cell. This is the negative, the biggest, and this is the Tempe treatment. Yeah, higher than this one, but still smaller than the negative control. Okay, NST treatment had a better bioactive components in decreasing damage to pancreatic beta cell than the GST treatment. Now I want to share the second topic about the hypoglycemic activity of fresh and overripe tempe, semangit, and bosok. I think most Indonesian people know well about the semangit and bosok tempe as a condiment, not as for fresh consumption, but for the condiment. Yeah. The objective of this research was to evaluate the effect of consumption of 6 types of tempeh on the function and morphology of liver, kidney, and pancreas and pancreatic of DM rats model. So we have 2 types of soybean, germinated and non-germinated, and also 3 types of tempeh. This is germinated soybean, this is non-germinated soybean, and this is the 3 types of tempeh. Fresh tempeh means 2 days fermentation, semangat tempeh 5 days fermentation, and bosok tempeh 8 days fermentation. So this is the interesting result about the blood glucose reduction curve of the M rats after 28 days feeding. This is the reduction, yeah. This is the 0, of course, and this is the this is the reduction curve of blood glucose. This is the control positive with gliclazide. Gliclazide is sulfonylurea anti-diabetic drugs. Of course, this drug will decrease the blood glucose significantly higher as other group. But a tempeh group here, yeah, germinated and non-germinated, also has had a good perspective in reducing the blood sugar, as you can see here, significantly different as compared to the negative control and also positive control without drugs, yeah, without the anti-diabetic drugs. And this is the IC50 free amino acid and insulinotropic amino acid. Yeah. So we can see here the bosok non-germinated had the lowest IC50 of antioxidant, the lowest IC50 of alpha amylase, and also the lowest IC50 on alpha glucosidase. Yeah. But for the free amino acid, especially for the insulinotropic amino acids, had the highest value as compared to other groups. Means that BNG is very prospective to use as blood glucose reduction. Yeah, and this is the pancreatic beta cells profile. You can see here that the diabetic with bosok non-germinated significantly had beta cell number higher than other group, but not significant as compared to the negative control. This means very good. Yeah, this is very good. Yeah. And sorry. Okay, this is the profile covering superoxidase smoothase antioxidant in various tissues. This is in the liver. You also can see that DBNG is the significantly higher than other tempeh group. And then this is in the kidney. You can see also from this picture, yeah, not significant as compared to the negative control. And this is in pancreas, yeah, also not significant with the negative control. And this is some of possible mechanisms that we propose why isoflavone and pre-amino acid, yeah, can maintain the or can increase the profile of covering SOD, or decrease of MDA, and also decrease the cell damage in liver, kidney, and pancreas. While this is the insulinotropic amino acid and alpha glucosidase inhibitor can reduce the blood glucose. This is some mechanism that could be occurred in the system. So as a conclusion, the soybean germination process could increase the hypoglycemic activity of pressed tempeh. All types of tempeh flour could significantly reduce blood glucose level in DM rats, although they have not been able to match the action of gliclazide. Among tempeh flour, the non-germinated bosok tempeh flour, or BNG, was the most effective in lowering blood glucose in DM rats. The BNG contains more bioactive components, such as isoflavone and others, that play a role in hypoglycemic activity, like antioxidant, yeah, anti-amylase, alpha glucosidase, and also free and insulinotropic amino acid. All components in the BNG have been shown to be able to reduce reduce oxidative stress in the liver, kidney, and pancreas, as well as assist to the recovery of pancreatic beta cell and GM-RATs. And the improvement function of pancreatic beta cell will increase the insulin production and also glucose absorption in the cell and lower blood glucose. And this is our diabetic research team. We work together in doing this research. And finally, thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Pak Made. Thank you so much for your wonderful talk. I also learned a lot about the latest scientific finding regarding the use of germination to promote the improvement of the anti-diabetic activity for tempe. So we all know that tempe is a very healthy food, lots of health benefits, and Professor Made is one of the scientists that have published many research regarding the benefits of tempeh. So before we go to the next speaker, I would like to welcome back Ibu Konjen Diana, who would like to offer her own perspective regarding the prospect of tempeh and the tempeh diplomacy in general.
Yeah.
Please, Ibu.
Okay, thank you, Professor Dr. Sastia. I apologize for asking to take the floor again, but I just wanted to highlight a little bit about what we have done at the Indonesian Consul General in Osaka, where we have been supporting the promotion of tempeh as part of our economic diplomacy, where we are now trying to focus as well on tempeh diplomacy. So our efforts will not made possible if we are not supported by many players, many of our partners here, including Dr. Sastia, who just recently, since last year, she has successfully brought Indonesian made tempeh to Japan. I remember when the first batch, a container of tempeh was going to be shipped to Japan, we had quite an intensive discussion, Ibu Sastia, and how to ensure that the tempeh that will be shipped to Japan is all of them are safe, ensure their safety and also the quality. So that's why the Consul General of Indonesia in Osaka assisted in linking the efforts to ensure these two important criteria for imported products to Japan, the safety and quality, by linking it with the Indonesian Food and Drug Authority that gives the certification. So congratulations, Dr. Sastia, for making it happen. So Indonesian made tempeh is or has been in Japan right now, and science could make it possible. So tempeh could now, ladies and gentlemen, colleagues, friends, tempeh could now be easier easier to spot on in big chain supermarkets in Japan, including such as Gyomusupa. So whoever misses tempeh, even myself, go to Gyomusupa to purchase this superfood. I would also like to consider this for all of us here in the Indonesian Consul General, that this is one of achievement in Indonesia's tempeh diplomacy. So I would like to continue promoting, assisting, facilitating myself and also my team at the consulate to everyone that will help the promotion of Indonesian food, Indonesian culture, more widely known in Japan. So thank you again for this opportunity and have a wonderful discussion.
Thank you very much. Messages and encouraging positive messages for us from the academician as well as from the industry point of view to want to work harder and collaborate stronger as well in order to achieve more and more promoting tempeh worldwide. Okay, so now we are already listening to Professor Made's talk. And before we give the chance to Dr. Puji to give a talk, perhaps some students would like to ask some questions regarding Professor Made. Any questions from the audience? Okay, so later on, maybe after Dr. Puji will give her talk, maybe we will open for question and answer.
Yeah.
But maybe if you have any questions, the chat room is open. So please feel free to ask your questions to our speakers at any time during the talk. And then later on, after their speech, we will give a chance for the speakers to answer your questions through chat. Okay, so is it okay to start? All right. So okay. So now, Pak Made, we thank you again, and please stay with us for listening to the questions.
Okay, you're welcome. Thank you very much.
Yeah, thank you, Pak Made. Yeah. Now we are going to play the slide from Dr. Puji. Dr. Puji here is with us, the new chairwoman of Research Organization for Food and Agriculture, BRIN. And she will be talking about the development of tempe as the Indonesian superfoods. Okay, the time is yours, Puji.
Terima kasih, Bu Sastia. Thank you, Dr. Sastia. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. First, I would like to thank Dr. Sastia again and to Diana, Vice Chancellor of KJRI, Vice Rector of IPB University, Raja, and the Pak Made, one of the resource person expert of tempe, and Mas Andu, Miss Andu, Andu, and our members in this consort. Nice to see you all, and BRIN, thanks a lot and appreciate highly to give chance to talk in this moment. Actually, I'm not expert of tempe. I just would like to share current progress or research in BRIN, and basically actually what is result produced by previous organization that have been integrated into BRIN. So as mentioned by Dr. Sastia, it is about development of tempe superfood. Next. And the research organization for agriculture and food is one of research organizations in BRIN out of 12 research organizations dealing with any food or agricultural product, including tempe. And actually, Pak Mades already shared a lot about tempe and related to human health. And here is some of these are maybe similar, but we focus on some of the kind of breeding or what kind of variety are suitable for tempe, and how we will develop or how we will release a new soybean variety or others that can be developed for tempe. Okay, here as we see that, yeah, tempe is mostly made from soybean, and it's here the supply the largest need of protein. You can see here, and then consumption is 7.35 kilogram per person per year, and tempe producer here from small and medium enterprises, so high, and at least 100,000 producers spread out in the provinces in Indonesia. It's big. I mean, tempe is exactly reached from Indonesia, so the need of soybean is very lot. In 2015, you can see here is very high. It's almost maybe 1 million ton. So only 30.5% was supplied by local soybean. Is one of challenge. It's the most challenging how we could provide soybean variety, and it's mostly actually the import and maybe GMO, right? We don't know. It's mostly GMO. Okay, next. So it's just okay. This one is how is the specific characteristics of soybean for food ingredient for tempe. At least the weight is at least 14 grams per 100 seeds, and maybe people like yellow seed, but for tofu and flour or soy milk, soy sauce, others they have specific what kind of soybean grain. So for tempe, basically we have specific characteristic. Next. That's why we have to push, or we have to explore on breeding. So here, soybean processor and consumer get used to imported soybean is one of, okay, it's the problem. And Tempe and tofu processors tend to select imported soybean. We don't know why we prefer to have the big one, I mean, the imported soybeans grain, because I think I don't know, the taste, everything may be different. So here we would like to introduce, so the use of improved varieties need to be promoted and socialized. Actually, we have a lot of research on local genetic research, local soybean, how we could compare with the imported soybean. So a number of improved variety available with large seed size similar to imported soybean, even larger of them. Next. This is example that's suitable soybean variety for Tempe. If you see Burang-Arang is one of soybean variety, has bigger than imported soybean. Also, there is this is Tempe volume, and it's a correlation with the weight each 100 grain. Next. So the relation between 100 grain weight and yield recovery of Tempe, there's a positive correlation. Here you can see that each is yield recovery and also 100 grain weight. So how we could produce this specific soybean grain for this, for Tempe. Next. So mostly actually before we integrated to breed, Ministry of Agriculture, also maybe other universities or other research organizations already released a lot of soybean varieties with large seed. And for example, it's Grobogan and Anjas Moro. This released many years ago. And till 2015, Dena and Dega, also Busoy, this little recently before pandemic, I think Busoy, 2000. And I'm one of the breeder is Busoy. It's released by Ministry of Agriculture, and it's people like Busoy for Tempe. Yeah, this is only one of the parents from China. China and Japan. This Japanese study, the Japanese soybean variety and cross, and then do physical mutation with gamma irradiation. And then there is a specific characteristics of each variety compared to imported soybean. Actually, according to weight, length, height, and thickness, still comparable. Even pure soy, the weight is higher than imported soybean. Here, 25 something, and also length, everything. I mean, our genetic resources still comparable and good if we could socialize the use of our local genetic resources. Next. It's just additional on the amino acid here, so it's still comparable with the imported soybean. There are amino acid here. You can see that like Anjas Moro, Busoy, Grobogan, Dina, Diga has high amino acid. And we could next, you can see next, okay, here. So this proximate composition, moisture, FOKS, and protein, because we can, according to protein, I don't know this, based on the calculation of some researcher has maybe gap of different data. It's even the same variety, maybe depends on the, I don't know, machine or, but here you can see that for imported soybean, the protein is about 16, but Dega, also Anjas Moro, Grobogan has higher protein. And also fatty acid is still linoleic. It's unsaturated fatty acid is very important. So imported soybean also here, you can see that we use our local varieties. Next. This is additional. This table is similar to previous one, but other teacher too. So there is just different data, but at least we can compare how our varieties produced from breeding or other mutation we can explore for its use for tempe. Next. Maybe Mas Ando will know better about how to develop tempe. This from sortation boiling in Australia. Is from the time for each step. It takes how many days for making tempe until we have tempe? 3 days. 3 days or 3 days from sortation.
From soaking.
Shocking. Okay. Before shopping, this year process of sortation bottling has been continuing for
almost
all.
5 days. In total, almost 5 days.
And when I was child, I remember my neighbor, they made tempe and they used their food just to
Remove the
the peel, the peeling, I know myself because I watch, but I eat. Okay, this years, but I think that the way how they do still the same. Right. Yeah, this is 4 more. Just figure them next year. So how each step can be explained here from sortation, just step by step until we have tempe. Next. Okay, here one is one of technology resulted from BREEAM. They develop kind of machine, especially to reduce the use of water spilling by dry milling prior to cooking. It can make efficient and save time under 33% and save water also under 33%. This belongs to appropriate technology under BREEAM and the restoration for agriculture and food, and they have this machine. So I mean, because as mentioned by Budiana, how we could internationalize tempe, so maybe a lot of scientists and technology could support this, including and Mas Ando and everyone. So here goes Sastia to export import tempe. So how we could make it tempe to be in the global level. Next. So this tempe prepared from selected soybean varieties, just different varieties. So of course the preference is on consumers. So the quality of tempe from improved varieties is similar to those of imported soybean. So there are no different. If you can see yield recovery by weight on Burarang, Bromo, it is those are improved varieties is much higher than imported soybean. The imported soybean only 138.4 for yield recovery. Next. Okay, and next is tempe. We try to make tempe from the variety of size of soybean grain, small, medium, and large. And the small rod has yield recovery in the higher 172, even but imported soybean only 155. So how we can do more for this, and maybe with the sorry formulation, I don't know. So which one are preferred by people for daily diet. Next. So this is also just example tempe from improved varieties and imported soybean based on the physical characteristic, but based on the odor and taste are similar. But other characteristics, especially like the tempe protein content higher than imported soybean. Dina 1 is 48, is almost maybe 50, but imported soybean only 45. And yield recovery from global is very high. So even higher than that of imported soybean. So here, yeah, on the next. It's just other characteristic, physical and chemical characteristic of tempe from soybean cultivars. Actually, some of this just like promising lines compare with the improved varieties and soybean imported from USA. So here, just again, you can see the potential use of overall local or improved variety in Indonesia. Next. In addition to that previous research, we also try to use other legumes, is koro padang and kacang gude. And because we are, our mandate is on agriculture and food commodities, and also how in Indonesia we have a lot of marginal land, so how we could use this kind of plant like this one, like kacang gude, because they're growing on marginal land. So how we could optimize all of that land for Indonesia. And of course, we don't need to have competition with soybean and fresh milk time. Okay, next. It's just tempe innovation product. Example is with can, with packaging process product can tempe is by, if you see, Mas Adi, you could visit one of the research center in Gunung Kidul. They have the research, Mas Patriot. Canned tempe and then sweet thick tempeh, and also what else? And the other super supplementary feeding for toddler. So any research, some of them have patent. So then based on, because we promote for functional food. Okay, for cake, any snacks, contain tempeh. Next. Just local resources, just before Liti did this, so because too green, so it just make the each from 2011, and then how they start research on tempeh, and then until 2020, I start to add the fortification, and maybe by fortification later on legume to be suitable with tempeh and good for health. Next, also here tempeh with add on spaghetti and any pasta. And next, you can see here now, because gluten, I see some people who have autoimmune or sensitive to gluten. So how we produce gluten-free noodle? Yeah, they do this. It's under a dream. So with cassava, flour, and beets with tempeh and beans. Yeah, this way. This that's example of tempeh product. Not only for the product, but we publish in international level, international global published paper based on the data on tempeh, sugar chemicals, sexuality and cooking, and also other research. And it happened next. This is implementation on the technologies there. Subang, this Subang is one of research center at the BRIN. This focus on appropriate technology, machinery, and equipment. So how they could support research on tempeh. So actually, I already informed Andu that in BRIN we have a platform and funding for research collaboration between BRIN and startup industry. Also, it's free and it's every year. No, just every year we can submit, and there is a batch 1 or 2, and we have system that we could collaborate for how to improve tempeh, to develop tempeh future. Not only just research, but how people that adopt or like tempeh, and also I think so. That's all. That's all our presentation.
Presentation from Ibu Puji, and so informative. I think Ibu Puji touched two very important keys of tempeh research in Indonesia, and I think her research is so necessary because every time people ask me, oh, you can export tempeh to Japan in large scale, but the soybean you still use import. Why don't you use Indonesian soybean? Actually, there are a lot of challenges why Indonesian local cultivars still cannot be used to make tempeh in such a large scale. It's not enough, basically that. Not enough. The production is not enough, and due to the high cost of production, tempeh will become expensive at the moment. So this is not very friendly for small, medium scale enterprises, for local producers, and also for the people. We eat tempeh almost every day, and if it becomes not affordable, then this is also not a good solution. So it's not because we don't love our country's product, but we need to make our local product affordable, accessible, and produced in a way that can be used to replace the imported ones. Of course, it takes time, and the folks at Green have already did a lot of research and survey with backup data that actually has a very big potential. So there is one important point. And second important point also, Ibu Puji mentioned about the innovative products. I was very interested to see like there's pasta, gluten-free noodle, and Tempe Queen here was like, oh yes, this is I thought very nice product, because now in Japan, there are a lot of people who are allergic to gluten, and therefore they have to avoid eating many different kinds of food. So this is one of the potential solution where tempeh can be used as an alternative ingredient. So very good information. And finally, people who are in the industry and startup, Ibu Puji mentioned that there is a funding available from the Indonesian government to support this kind of startup. And tempeh is one of our most proud heritage of Indonesia. So definitely very open, I think, to for the government to provide support to make this kind of startup with innovative products of how we can better utilize our local resources, utilize our food, local food, but then make it into the next level. Okay, so I'm very thankful for Ibu Puji for your wonderful insights. I think we will definitely have questions later on from the audience. Perhaps if there's already a question from the chat, please inform me. And before we go on to question and answer, actually today we have two PhD and three PhD candidates, two of which have already defended their PhD dissertation. 2 weeks ago, they have already successfully passed the PhD defense and are now waiting to be formally inaugurated as a new PhD in Tempe. One of them is still ongoing, probably hopefully next year. So we have 3 PhD students here with us who are going to be giving their research findings. And I asked them, because of course their PhD dissertation was 30 minutes long, but of course we don't have that much time to listen to their talks in detail. But I would like them to please say in easy to understand manner. Who will start first? Hadi. Okay. Hadi Dahlan Akbar is our PhD student from Malaysia, and also he likes tempeh very much, and is very good at cooking tempeh. So Hadi here is going to be giving us his research finding on the use of metabolomics, our research, which is the comprehensive profiling of metabolites, in order for us to optimize the production process and make better tempeh with better quality. Okay, Hadi, time is yours.
Okay, so let me change the. So okay, everyone can hear? Yes.
You can remove your mask because you're far away from everyone.
Okay.
We can better see you. Okay. Okay. Go ahead.
So, Assalamualaikum and good day, everyone, in Indonesia and also in Japan. Konnichiwa. So today I'm going to present a short presentation about what happened if we use vinegar during soaking and crush the soya beans. Yes.
Is it still muted? Yours?
No, they're
over there. Oh, okay. All right.
So again, during tempeh making process, this is the steps. The soybeans will first soak and then cook. After cooking, the skin will be removed and it will be dry. After drying, the tempeh starter culture will be inoculated and we package it, become tempeh. During this process, soaking process is the important step. For all those tempeh makers, you see when we soak the tempeh, we can see there's some bubbles and the water can also become cloudy. This is because of bacterial fermentation, during the growth of lactic bacteria can actually prevent the growth of spoilage bacteria that can make you sick. These bacteria go at a specific temperature. If the temperature of the soaking water is not optimum, then different kind of bacteria will grow. This bacteria, for example, like Bacillus cereus, can grow on the soaking water and soybean. This will then prevent the growth of Tempe mycelium, the white part. So in Indonesia, the country is at the equator, so it's easy to make tempe. The equator, the temperature is around 30 degrees. So if you want to make tempe, we just put it as it is, at room temperature, just as it is, and voila, the tempe will go. But other country, they can also make tempe. For example, this is tempe from Netherlands, from Japan, from Spain, and even from America. This country, actually, the temperature is not 30 degrees. Some of them is in winter condition. So how did this other country control the soaking process? So this country, actually, what they did is they add vinegar during the soaking process. So during vinegar, they will prevent the growth of bacteria during the soaking process. And even though there's no bacteria growing, including the bacteria, the soybeans can still be fermented into tempe. But one question remains. Does adding vinegar affect the taste of tempe? Nobody knows. So this research is going to study about it.
You probably should try. Taste it.
So in this study, we just make two types of tempe, normal tempe and vinegar tempe. We do metabolome analysis, and we do sensory evaluation. And this is the process making step for tempe. Basically, for vinegar tempe, we just add vinegar during the soaking process. So like I mentioned just now, we did sensory evaluation. But what is sensory evaluation? Sensory evaluation is an evaluation where we ask some volunteers to taste the tempe. Two things will be given to them. First, the cups containing the tempe, and second, a survey containing all the attributes that we are going to ask them. And based on this result, before that, this is the picture of the sensory evaluation conducted in Osaka City. So majority of our volunteer is our first-time tempe consumers, Japanese consumers. From 16 attributes, after we do our calculation, we found only 5 attributes to be significantly different between normal and vinegar. The 5 attributes are golden brown. Normal tempe is much more darker, as felt by our volunteer. And our volunteer also says that the normal tempe is much more salty and have stronger ammonia smell, much more stinky. But vinegar tempe has much more pleasant smell. So because of this, vinegar tempe is the most accepted by the majority of our Japanese panelists. Next, we also did metabolomic analysis. Metabolic analysis is okay. Metabolic analysis is analysis where we measure the metabolites. So what is metabolites? So for your information, we are all living organisms, and organisms are consist of molecules. These molecules include lipid, fat, carbohydrate, protein, everything. But there's still a large group. In fact, there's a much more smaller things that make it up. These things are called metabolites. Just for example, in proteins, they are the amino acids are the metabolites of the proteins. Metabolomics analyze the metabolites. So this is the result of the tempe analysis just now. As you can see, we did an analysis called principal component analysis. So the left side shows the tempe samples, and the right side shows the metabolite of the tempe. For easy understanding, let's see at the position of this, position of the metabolites. On the left side, we see the vinegar tempe, and you can see everything metabolite is positioned on the left side it means that it is higher in vinegar tempe. Any metabolite that's on the right side means it's higher in Koto tempe. And based on this analysis, it shows that much more majority of the metabolites are higher in Konto tempe, the normal one. As a conclusion of this, we found that Konto tempe, when we add vinegar to the tempe making process, majority of the metabolites decreases But because of this decrease of metabolites, people at least in our Japanese panelists, they like it more. So lesser metabolite lead to more acceptance by new consumer. Doesn't this means the vinegar tempeh has reduced nutritional quality? Yes. But maybe we can control that. So in this case, we introduce another process. We crush the soybean. So crush soybean. And after we crush, they can still become tempeh. And the next study, we did that. We study what if we combine vinegar soaking and crushing process, maybe we can produce a more nutritional and more acceptable tempeh. So again, there's now, instead of 2, there's now 4: normal, crush, vinegar, and vinegar crush. There's 4 types of tempeh. We then undergo the metabolic analysis, and we can see there's a difference. When we perform the analysis, we can see that the normal one, control and vinegar, the not crushed vinegar, not crushed tempeh, are positioned on the left side. And there are some metabolites which are higher in the left side, but majority of the metabolites are higher on the crushed types, which means that crushing actually increase the metabolites intensity. When we investigate more, we found out that the crushed metabolites has higher antioxidant metabolites. For example, these 3 metabolites. And also the crushing process increase the metabolite citrulline, which has been found to be potential to treat inflammatory bowel disease. Sakit perut. Then how about the taste? We already know that crushing process increase nutritional metabolite. How's the taste? So we did again another sense evaluation, and when we see the result, we can find out that the control and vinegar tempeh had high intensity of pleasant, but lower intensity of golden brown ammonia smell and aftertaste. Meanwhile, the crushing tempeh has much more golden brown color, ammonia smell, and aftertaste. For us Indonesian, maybe we like this one, but for the Japanese panelists, they don't like it. So they still like the vinegar tempeh. So as a conclusion, if you're a tempeh producer in a place where there's not commonly consumed, you can add vinegar soaking into the tempeh making process. Use the vinegar local vinegar. If you're in Netherlands, use that local Netherlands vinegar. And this conclusion for this study also, if you crush the process, it can increase tempeh nutritional value, but the taste might be not so good for the local people. So you need to make further strategy to make it more acceptable by new consumer. With that, I conclude, and this is a publication based on this study. Thank you.
Once again, who have already successfully defended his PhD dissertation. He has already officially passed and meet the requirement to become a PhD. Hadi, and will have his graduation soon in September. So soon to be Dr. Hadi. Thank you very much for sharing your thoughts.
Tempe.
I hope that your stay in Japan is going to be very fruitful experience for you to further develop tempeh in your home country in Malaysia. I think Malaysia also like tempeh, so I hope based on the interaction made in Japan and also interact a lot with Indonesian people, you will become the tempeh king of Malaysia in the future.
Get tempe king.
Yeah, sekarang we're going to move on to the next speaker. It's going to be another doctor, soon to be doctor of tempeh, Dela Rahmawati. Okay, and who is also having her birthday today. So this is a two celebration. First one, she has successfully defended her PhD dissertation on tempeh, and although they are both doing research on tempeh, how come there are 3 PhD students? But you will see later that they are working on completely different research topics, also about tempeh. And Dela was also featured recently in Kompas. Yeah, and it went viral also as one of the scientists in Indonesia that discovers the chemical map of tempeh by using tempeh produced from many different legumes. So her research is I think similar to what has been developed in Indonesia. I think in Indonesia we don't only produce tempeh using soybean, We also use other legumes. And but how about the metabolite content of these different legume tempeh? It's going to be the focus of Dela's talk today. Dela, please, time is yours.
Oh, okay. Okay, thank you very much, Sastia Sensei, for your nice introduction. So maybe had you already give a talk, very nice talk with the introduction of the tempeh and what is the metabol mix. But now I would like a little bit different, give a different talk with Heidi. What is the differences between my research and Heidi's research? Actually, Heidi's research is related to the soybean tempeh, but for me, I have a talk in the different legumes of metabolic profiling. So we discover more of like carbohydrate, for example, like that, but from different legumes. So let me start. So I would like to start with the stunting, because actually my purpose of to discover metabolites in different legumes tempeh, because this is much concerns, because we know that stunting is defined as a low height or age result of chronic or undernutritious diseases, and reducing stunting below 30% is one the first of 6 WHO global nutritional targets in 2025. And also in brain, maybe Bu Puji, correct me if I'm wrong, like reducing stunting is also one of strategic program that I know in brain. So however, stunting, actually there are several factors that can cause the stunting. One of them is inappropriate feeding and care in early life, which is the baby. That's why here I would like to say that food product with complete nutrient and balanced nutrient need to be provided in very early stages, for example, for the baby. So there are several like research previously that have been utilized tempeh as a weaning food, for example, in Nigeria. And in Indonesia, one of my colleagues also has been done to provide, to discover the utilization of overripe tempeh. Maybe previously, Prof. Madi already mentioned about semangit tempeh. That is recognized as overripe tempeh with the flop overripe tempeh as instant porridge, weaning food. And this formulation and development of nutritious weaning foods gain a lot of attention from a lot of researchers, because tempeh was considered as a food with complete nutrients and affordable with many benefits. So as you already know, maybe we know tempeh as a product. Tempeh is Indonesian fermented food, common from soybean. However, tempeh, maybe Mr. Ando also know that tempeh is about process. Actually, the process where half-cooked bean, originally soybean, are bound together with the help of rhizopus to be a compact cake. So we know that tempeh is a product. Actually, tempeh is tempehing, like a processing. So it can be from anything. It's not only from the soybean or maybe other legumes. But yesterday, Mr. Ando also talked with the coconut, tempeh from coconut, from other sources. So it's about process. So start from the sorting, soaking, boiling, until it's become a tempeh. It's tempeh. So yes, I already mentioned that tempeh has been produced from varieties of raw materials since long ago. And interestingly, that total protein content of those tempeh are comparable at the end of product, which is tempeh, even though in the beginning, in the legume part, the total protein content are varied. So as you already know, that the difference between each legume may be not that clear, because we never have a comprehensive analysis to exactly evaluate what exactly exists in our tempeh. That's why we need to find what kind of comprehensive analysis that we have right now to more comprehensively compile all nutritious compound that exists in tempeh to make an effective formulation, for example, for nutritional intervention. That's why here we propose metabolomics. As maybe Hadis already also explained, metabolomics is one of the omic approach to comprehensively analyze all of the metabolites in the biological system. here we have tempe as a biological system. And this metabolomic has been used to characterize the metabolic profile of fermentation product. Previously, kimchi or maybe soyu, something like that, has been done before. And also from the tempe, previously our senpai, who already graduated cadre, also has been done, the metabolomic profiling of soybean tempe produced in different places. That's why here we could say that metabolomic is useful tools to characterize comprehensively metabolic profile legume tempeh for further product development. So my objective of the study is to investigate the metabolite and sensory profile of tempeh from various legumes and its possible correlation to sensory analysis result. Actually, my dissertation compiled from the characterization until preparation, until a drying process, for example, something like that. But if I talk it like completely, it will take long, because but here today I would like to present more only the profile of the each legume tempeh. So the legumes that I use actually coffee bean, soybean, red kidney bean, and jack bean. So all of the soybean were brought from Indonesia and produced both in Japan and Indonesia. Thanks for Prof. Made also for letting me making a tempeh in Rumah Tempe Indonesia and conduct sensory analysis there. Then after that, I also making a tempeh here in Japan, but because of temperature difference, I use it incubator in 30 degrees Celsius for soaking and mold fermentation stages. So next, I also try to find a local Japanese local legumes that I can find in Japan supermarket, like green soybean, what we call it edamame, and then garbanzo, white bean, and green pea. There are a lot of local legume in the supermarket. I'm trying to make tempeh also from this kind of legume and also produce it in Japan. And for this metabolomic analysis, I use two tools, which is GCMS analysis, gas chromatography mass spectrophotometry, to more comprehensively look at the small hydrophilic compounds, and liquid chromatography for amino acid, and do sensory analysis. So for the result, maybe it's a bit complicated, but I'm trying to make it simple. As you may see in the left side, all legumes are clustered together, meaning that the fermentation process significantly changed the characteristic of the legumes. So before fermentation, the legumes are clustered in the left side, but after fermentation, most likely they are clustered together in the right side. When we look at the loading plot information includes what kind of compound that is represent to each side. For here, we could see that the blue one, the blue dot, are corresponding to the tempeh part, which is amino acid. So here we could say that the amino acid increases after fermentation significantly. And when we look at to each for first, I combine legumes and tempeh, but when we only look at to each legume, totally different. They cluster differently. The soybean was clustered together with the coffee bean in the left side, and red kidney bean were clustered together with the jack bean in the right side. Actually, what makes them different are the metabolites. The things that I found is the soybean tempeh is having a different amino acid profile with the red kidney bean. So if we combine it together, maybe it could be compile each other like very suitable. So we have like complete formulation of amino acid if we combine them together. And interestingly, when we do the sensory evaluation, the similar result also we found similar. Like red kidney bean tempeh were clustered together, like in the left side with the jack bean. Previously here, jack bean and red kidney bean also clustered together, and soybean and coffee bean tempeh also clustered together. So actually, metabolomic analysis also maybe having a similar tendency with the sensory evaluation. maybe as we already know that sensory analysis is one of powerful tool to investigate the character of the food product, because nothing can replace our like mouth, five sense, human sense. There's nothing that can be replaced, but metabolomics could predict like this the characteristic of the bean, the seed actually. And for the other beans that I bought in Japan, local legumes, actually the tendency also different. Like soybean and red kidney bean, previously in Indonesia, we found it's different, but here we could say that it's clustered together. Why make it them clustered together? Because for example, green pea soybean and white bean tempeh has been having a large difference, like the significant difference in another metabolites compared with the tempeh that is produced in Indonesia, which is soybean and red kidney bean. It could be like amino acid, for example. Here we found that aspartic acid and glutamic acid contributed more in the tempeh that is produced in Japan. So tempeh that is produced in Japan and tempeh that is produced in Indonesia also different in the amino acid profile. And if we look at to more detail only in amino acid, yeah, like this. It's interesting also. Like white bean were accumulate all the amino acid, which is good, I think, because we cannot produce it in our body. Like essential amino acid also having a cluster, having accumulated in those legumes also. So it's interesting. So I mean here metabolomics could give a more comprehensively result for the tempeh that we have. As a summary, as I already mentioned, there is significant difference in the metabolic profile of legume before and after fermentation in different production places, also in Indonesia and Japan. And based on GCMS analysis result, coffee bean and soybean having similar profile. This finding also found similar in sensory analysis results. And based on GCMS analysis, white bean and green pea tempeh were clustered together and accumulate high accumulation on aspartic acid and glutamic acid, while we look at the LCMS analysis, L-amino acid were accumulated more in green pea, garbanzo, red kidney bean, tempeh. So based on my study, I found that all legumes are suitable to be developed in for food with the good protein quality. So if we would like to further develop like nutritional intervention food product, tempeh one of the good source. Like that. I think that's all for me, and this is my publication.
Birthday girl, for delivering your nice talk about the differences of different legume tempeh. And actually, this is the first step of her study. The second step of her study is also regarding the development of baby food ingredients later on to solve the stunting problem in Indonesia. So we hope that soon the implementation of this research will be very beneficial to solving this very serious issue in our country. Thank you very much, Della. So next up, our last speaker is Marvin. So Marvin is actually a PhD candidate also in my team, and he still has about a year to complete and defend his thesis. Marvin has a very different research topic compared to the other members of the tempeh team, because his research is very interesting. It's because he explored using novel approaches. What are the things, hidden metabolites that actually are available in tempeh, but people don't know it yet. So his research is very, very new. And we're so excited about the latest progress we have in collaboration with Harvard University Medical School. So this research is conducted in collaboration with Harvard Medical School in the epidemiology to test in large-scale population later on regarding the use of these new metabolites in promoting health benefits in tempeh. So actually, this research is not yet published, but we hope that we could soon make this paper available. And Marvin, please, time is yours.
Thank you very much, Sastia Sensei. Good afternoon, everyone. So as Sastia Sensei said, actually my research deals a lot with data. So the first thing that I want to talk about is data itself, in particular metabolomics data. So first, maybe my colleagues before has explained to you what metabolomics is, but to just make it even more simple, so metabolomics analysis or food metabolomics analysis is basically when you take different kinds of food and you analyze it using various machines that is available in our lab, and then you can find out what metabolites, what things are inside of our foods. It can be something like amino acids. Maybe you're familiar with different types of amino acids. It can be like sugars, organic acids, and other small molecules. So what we do in our labs is we take different kinds of foods, including tempeh, and we run it through our machines, and then we find out these kind of data. So just to make it simple, food metabolomics can tell us what metabolites and how much of these metabolites are inside of our foods. Now, in Fukusaki laboratory, we have analyzed different kinds of food over the years. We've analyzed foods such as coconuts, pineapples, tropical fruits, bananas. We've also analyzed like processed foods such as coffee or chocolate even. And also some of our Indonesian fermented foods such as tempe and terasi. And actually one analysis of any of these samples, we can get around 50 to 200 different metabolites. So you can imagine how many metabolites we have collected over the years, analyzing different types of foods, different kinds of treatments. And yeah, over the years, our lab has accumulated a very, very large collection of metabolite data. And what I did with my research is I looked into these data, this collection of large data, and I employed some data mining techniques. Basically, what I want to look for is I want to look for unique metabolites that have specific health benefits, but are less known. So it is not your common metabolites, such as maybe isoflavones or other, maybe GABA or other things. I wanted to look for specific metabolites that are less known. Now, in the beginning, I didn't plan to do tempeh research. My goal was broad, and anywhere it leads me, I will go. So I was looking into coffee. I was looking into chocolate to find this like new health metabolites. But then it led me into tempeh because I found a particularly very interesting metabolite to me in tempeh. This is the metabolite. So it's called maglutol. It's 3-hydroxy-3-methylglutaric acid. So it's a relatively simple metabolite. It is potentially healthy because some of the previous studies, only few of them are available, but they said that maybe this has the potential to reduce, cholesterols in your blood. So I was really interested in this. And when I looked into the previous publications, I saw that only very few publications before discuss about this particular metabolites. And when I looked into our big database, I found that this metabolite is very high in beans, but even more in tempeh. So I was very interested when I find out about this metabolite. Now, when I know that tempeh fermentation alters the inside the contents, metabolites of the tempeh, I checked the maglutol content, and what I found was that when I compare the maglutol content before fermentation and after fermentation, it increased fairly significantly. So it means when we ferment soybeans using our starter culture, our fungi, Rhizopus oligosporus, it somehow, in some way, it increases this very healthy metabolite in tempeh. Then I started thinking, because I found this metabolites also in other beans. And when we compare it to other beans, actually other beans has naturally more maglutol content compared to soybean. So what will happen if we ferment these other beans using Rhizopus oligosporus as well? So that's exactly what I did. I selected 4 different other beans, particular because these beans have been optimized by Mbadela before, the fermentation process and everything else. And we know that it has excellent amino acid contents. So I chose this for different beans. I fermented white bean, red kidney bean, green pea, and edamame. And I was particularly interested to see how this fermentation process affect the maglutol content. Interestingly, for each of these beans, when we ferment them into tempe, they have increased maglutol content, some even up to 2 times or 3 times. And what I found is the highest maglutol content, I found it in green pea tempe. So first, I found that all alternative tempes made from alternative beans have better maglutol content. And in particular, I found that green pea tempe has 10 times more maglutol content versus soybean. So if you want to have maglutol, if you want to eat maglutol, from this research, I can suggest you to eat green pea tempeh. But the question still remains whether maglutol itself is really a healthy metabolite or not. To answer this question, so we collaborated with Harvard University. So in their study, they deal with a very large population. So they have a very large population data, and they have the data of the metabolites inside the bloods of people. So you can see in their data that some people have low maglutol in their blood, and some other people have high maglutol in their blood. And then when they compare between these two groups of people, what they found is that when you have low maglutol in your blood, you have high LDL cholesterol levels, which means that you have higher risk of cardiovascular diseases. On the contrary, when you have high maglutol in your blood, you tend to have lower LDL cholesterol, and in turn, you tend to have lower risk of cardiovascular diseases. So yeah, my talk is really short. Basically, I conclude that eating foods with high maglutol, such as tempeh, it can potentially lower your LDL cholesterol levels and help reduce the risk of cardiovascular diseases. Of course, there are still a lot of things that need to be explored more, particularly in maglutol inside tempeh itself. That's why I was very, very interested in Professor Made's talk when he talked about using rats to study diabetes, the effect of tempeh to diabetes. I would love to collaborate with Professor Made if I have the opportunity, and hopefully I can also do these kind of things. So with that, that concludes my talk. Thank you very much.
Finding and new ways to take a look at the data that we already have. Sometimes we focus so much on getting data and then forget sometimes once we have already accumulated so much information to actually utilize this data and find hidden meaning within that data. So Marvin is very, very smart to be able to capture actually something that is completely unknown about tempeh, and potentially this could strengthen the scientific basis on how tempeh can help reduce the risk of cardiovascular diseases. For a long time, people always say that probably the effect is due to the isoflavones, but perhaps your research could shed a light that there's not only 1 or 2 metabolites responsible for the various health benefits of tempeh, but for example, like this kind of maglutol. So it has a big potential to develop tempeh further as superfoods in the future. So thank you very much for today's speakers. And I would like to please the camera to our panelists for today's discussion. So today we are going to have this session into 2 different sessions. The first one, we have already listened to talks from our experts and soon to be experts, or maybe already experts, yeah. So from our experts in tempeh, and we would like to discuss further regarding what we have heard so far and what is actually their opinion. For example, Tempeh Queen later on can say something about what her impression is after listening to so many scientific talks and learning from the latest scientific findings. And Dr. Adriano is someone who is very passionate about tempeh and know a lot about tempeh and have already reviewed many latest articles of tempeh. What do you think about the significant advancement in research. So from now, we're going to close the Zoom. Before we close, we're going to just have a brief comment, maybe about a minute from each, before we move on to the next session, where we're going to have the Tempe talk show after this. Please, if you would like to say something, Tempe Queen. In Japanese is also okay, whatever you're comfortable in.
I'm so interested about the tempe more because I said so many I think before, but I don't know so many still. Like can be noodles, can be into the can, and there's so many
Nutrition.
so many benefit for the health, and then andなんかまだなんかいっぱい聞きたいことがあるからまだちょっと時間が足りない。
Okay.
Not enough for the time for talking about the tempe. I still wanna ask about the tempe to the student and to the professor. Yeah.
Okay, so if you feel like what you have learned so far also makes you even more curious to want to know more about Tempe. So we will answer your curiosity. Then maybe later in the talk show, we can discuss further about this. Thank you so much, Ms. Ando, for kindly gracing your presence with us, my queen. Okay, so perhaps Dr. Ando can also add a few words before we move to the next session.
Yeah, thank you so much, Dr. Sastia. I'm very impressed. I think Osaka University, the Tempe team, has done a tremendous work because what I want to emphasize is that despite all the difference, maybe the complexity of the Tempe world, Tempe science, we are actually in the same boat, right? I think we're continuing to do something that our ancestors started about 300 years ago, starting when someone in Klaten, Central Java, decided to, oh, I bring these boiled soybeans in the leaves, and when the person was hungry, I want to eat my boiled soybean lunch, and then when they open it, oh, what is this? It's now solid, and that person decided to eat it, and now 300 years later, we try to figure out still what health promoting that food is. So it's great that especially the Fukusaki lab has done a very sophisticated analytical method, metabolomics. It's one of the most cutting edge and analytical technologies in food science. It's very impressive, from something as simple as, oh, this new approach in Tempe in different countries outside of Indonesia, is it okay? Is it favorable to, can we do something to fight against stunting by utilizing different substrates using documentation, to exploring the underexplored area, the shadows in the Tempe science world, by finding new, potentially health beneficial compounds. So I'm very impressed. So I just want to say big congratulations.
Okay, thank you very much. With that, we will be talking further in the next room. So we will move from this platform in Zoom. We will see if we could connect later, but if not, then please follow us to join the live talk show through IG Live from Tempe Movement. And I also will have the IG Live from my Instagram, sas.tiaputri, and also from Tempe Queen later on. So many different people will go for IG Live after this, and we will have many different kinds of Tempe tasting as well available straight from Osaka, Japan. Okay, thank you very much everyone for joining us through Zoom, and see you all in Instagram. Bye. Pak Ade, nanti kami akan lanjut via Zoom, tapi di ruangan sebelah apabila Bapak mau join. Terima kasih Pak Made.
Okay, yeah.
Ya, oke.
All right.